What's going on, guys? Welcome to another Bash tutorial, and in this one we're actually going to start writing Bash scripts. So the reasons should maybe be obvious by now. First, if you ever want to reuse some code that you write in the shell, you're going to need to keep it someplace, and a text file really is the way to do that. Beyond keeping it, you may want to have a script that can take different parameters when you reuse it. So you pass it some arguments, and it uses those and then gives you output based on the argument you gave it. So for example, you have some script that does something to a directory. Well, you might want to, instead of specifying in the code itself which directory to do those things to, you want to pass that in as an argument. You can do that. Also, it's just unwieldy to keep doing stuff in the shell. Once you get too far beyond 1 or 2 for loops, it just starts getting unwieldy to debug and work with that code. So scripting, it's the next step on the path to Bash programming. Okay, the first thing I'm going to do is say which Bash. Now, the answer to where is the Bash binary or the link to it is bin bash, and that's going to be on almost every Linux system the same place, which is /bin/bash. And that is because the very first line of any Bash program you'll ever write will be the path there. This first thing, the shell just sees this as a normal comment, meaning everything after it is ignored. It's just like we remember from Ruby, or if you've programmed in Python. You have a comment symbol, and the interpreter just says, okay, I don't care about anything on this line. And this is where you'll leave comments for yourself, or this thing, which is really for the kernel and not the shell. The Linux kernel will see this and say, I need to run this with the binary found here. So this is called the shebang. You might have heard that before, which is just a hash bang, hash exclamation mark, whatever. It has lots of names, but that's what it is. So this is a message to the kernel saying, execute this here. And the reason is, when I save a file, if I call it .sh or .exe or .whatever, Linux doesn't care because file endings have no real meaning to Linux, to the operating system. Okay. That being said, when we save this, it is still nice to call things .sh for a shell script, just because people have to deal with this stuff that we leave behind, especially if you're doing this at a sysadmin job. Other people need to be like, oh yeah, okay, that's a shell script. I know what that is. And the other thing is, if you're using an editor, like I'm using Sublime Text here, a heinously unregistered copy, I might add, you'll also get syntax highlighting and all the rest. You see that comment actually just went dim or gray to let us know, this is a comment. And the simplest program we can write, or one of them, is simply the hello world program. As really we'll just echo out, just like on the shell. We're taking the exact same concept, hello world, and we're applying it in a script. So this is the first level of Bash scripting. You literally just take the commands that worked, that you tried and debugged on the shell, and you stick them in a script. A script's a little bit different because what you maybe didn't see on the shell is that functions or scripts, things that you do on the shell, have return values. Now, a return value is something that can be used by the program calling the script or the person calling the script. So return values will be something between 0 and 255. So 0, the exit code 0 generally means no problems here. You can think of it as the 0 errors encountered. And anything 1 is just sort of okay, there was some kind of error. But you can really use any number in here. If you have a very complex script, you could say, 12. Okay, but what you really would be saying is exit 12 or exit 0. So this means no problems encountered. It was fantastic. Exit 12 would mean we had error code 12, and whatever that means is sort of up to you. So leave that in the documentation, obviously. Or you can also just say exit without anything. And what happens then is that the return value from the last function or command you ran is returned as the script's return value. So this would say, all right, there's no number next to this, so let's just see what the last thing we called was. that was this echo hello world, and if that returns 0, we're going to return 0. If it returns something else, we'll return that. There's one more thing that you can do, and that is explicitly, it's doing the exact same thing as just a naked exit statement here, or bare exit, but it's a little bit more explicit, saying, I mean to do this. This is not just a mistake, and I'm accidentally just going to exit with whatever value my last statement returned, and hope that no one will ever needs the return value from this program because I'd never cared enough to specify. Well, this means I actually mean to exit with the return value of the last thing. So this, if you remember, this is how you call a variable, right? So if I said, we'll use a variable here like message, and then we'll just restructure this program a little bit. So this has now been restructured where we're calling, going and referencing this variable here and saying echo hello world, still the same thing. And now we're going to exit with the exit status of that last run command. Okay, so this is actually the same thing that we had right at the beginning. It just looks a little weirder, and that weird look is something you're going to have to get used to. Okay, so this is the same as echo hello world, exit, or nothing at all. Make sense? Okay. So we're going to try to run this, and we're going to have some problems. Here, watch. And you can already tell your auto-completion won't work. And that's because permission denied. What is going on? Well, if you do a long listing, you can see which bits are turned on here. Hello world. Well, we've got owner read-write, group read-write, and other read. What's missing here is the execute bit, the X. So we need to turn that on. What we need to do is change the file mode, add the execute bit, and then the file name. If you've never used chmod, you should just look up the man page for that. You'll be using it a lot as a sysadmin. So chmod, change the file mode, and so change the permissions on the file. And plus X just means please add the execute bit across the board, right? So now everyone's got execute permission. If you want to be a little more fine-grained with that and just say owner execute or someone else, only other execute, not that you would ever want to do that, but then you can do that by specifying the mask or the octal value for the permissions for that file. I'm sorry, not the mask. That being said, we can now finally tab complete because our shell is like, oh yeah, I know what's going on here. This is totally something I can execute. And we get back a beautiful hello world, just like we expected. Exactly like we imagined. Almost better than we dreamed. We're going to move this shell off to a new workspace. One of the things I want to just show you is that there's two other ways to run this program. There's two other ways to get bash to run this program. You could actually say bash hello world, and that would say, I would like a new instance of bash to be spawned to then execute this hello world program, Shazam. Or you could say source, or there's a shortcut for that. You could just say dot, but we'll say source, and then the program name. And what that would do is to take your existing login shell that we're in right now, and to run that source code. I just want to show you, if we echo, what do we call that? Message? That's not defined. But if we say source hello world, oh, I believe that's happened because of our magical exit statement, where we're actually exiting the shell. Let's save that and try it again. Source hello world. There we go. So now it's no longer exiting our shell, but what it's doing is executing it in our login shell. Now the weird thing is, since we defined a variable in there, when we echo the variable we set in there, we have it available to us. You saw we didn't have it before. So the problem with just sourcing something, you want to source something intentionally. This is not just how you run a script, because sourcing something basically takes your existing shell and augments it with the variables that are set in the shell that you're specifying. So what you'll see a lot of the time, for example, if you're ever setting up OpenVPN, you want to set up a VPN, one of the things you do there is before you start working on creating keys and stuff, what they've done is put a lot of the environment variables, like for your cryptography, your cryptographic certificates, they've put those variables in a bash script where they literally have just done things like your organization's name, and then you like fill it in, right, etc. And then as soon as you source that, all these things are in your shell, and then the other scripts that you run to actually create the certificates simply reference these variables that are set in the shell already, so they don't have to, so every certificate you create, you don't have to go through a wizard specifying the same information over and over and over again. So one solution for that is what they do, which is you then simply say, we'll source it again, right? So show you again, org name. We're going to try and echo this out. This doesn't exist. Now we source hello world. And it runs, it does its thing. So if something's printing to standard out, it'll still happen. But then when we try to echo that org name again, we have it. Does that make sense? I hope that makes sense. So to run a script, simply set the execute bit and then call it. Very simple. To source a script and to sort of integrate its variables into your current shell, into your login shell, use the dot notation. So this is the same as saying source hello world. Okay, these are the basics that you must know before you start writing bash scripts. And now you know them. So in the next video, we'll get started and actually start writing some ridiculously awesome scripts.